Good afternoon, my name is Jaco de Tooy and welcome to my interview. As a conclusion to exercise 5.7, we were given 5 questions to discuss. So let's begin. Question 1. What does the CRISP DM methodology for data mining entail, and what does the data analyst do in each step? So CRISP DM, which stands for Cross-Industry Standard Process for Data Mining, is an industry-proven way to guide your data mining efforts. As a methodology, it includes descriptions of the typical phases of a project, the tasks involved with each phase, and an explanation of the relationship between these tasks. The structured, thorough, and validated approach to data mining can be broken down into 6 phases. Phase 1. Business understanding. Any good project starts with a deep understanding of a customer's needs. The business understanding phase focuses on understanding the objectives and requirements of the project, and this phase can be broken down further into 4 sections. You should first thoroughly understand from a business perspective what the customer really wants to accomplish, and then define the business success criteria. Secondly, determine resources available, project requirements, assesses risk and contingencies, and conduct a cost-benefit analysis. Then, in addition to defining the business objectives, you should also define what success looks like from a technical data mining perspective. And lastly, select technologies and tools and define detailed plans for each project's phase. While many teams hurry through this phase, establishing a strong business understanding is like building the foundation of a house. It is absolutely essential. Phase 2. Data understanding. Next is the data understanding phase. Adding to the foundation of the business understanding phase, it drives the focus to identify, collect, and analyze the data sets that can help you accomplish your business goals. This phase also has 4 tasks. Firstly, you acquire the necessary data and, if necessary, load it into your analysis tool. Then you examine the data and document its surface properties like data format, number of records, or field identities. You dig deeper into the data, query it, visualize it, and identify the relationships among the data. And then lastly, you clean the dirty data. Document any quality issues you might find, and from there on you can begin to explore the data, calculating some basic descriptive statistics like the mean, the mode, or the median to get your first insights. Phase 3. Data preparation. A common rule of thumb is that 80% of a project is data preparation. This phase, which is often referred to as data munging, prepares the final data sets for modeling. This also has 5 tasks. First, you determine which data sets will be used and document reasons for inclusion or exclusion. Then, often this is the lengthiest task, so without it, you'll likely fall victim to garbage in, garbage out. A common practice during this task is to correct, impute, or remove erroneous values. Then, derive new attributes that will be helpful. For example, derive somebody's body mass index from height and weight fields. Fourth, create new data sets by combining data from multiple sources. And then lastly, reformat data as necessary. Phase 4. Modeling. What is widely regarded as data science's most exciting work is also often the shortest phase of the project. Here you likely build and assess various models based on several different modeling techniques. Now this phase also has 4 tasks. First, determine which algorithms to try, like regression, neutral net. Second, generate a test design. So depending on your modeling approach, you might need to split the data into training, test, and validation sets. Then you need to build the model. And lastly, you need to assess the model. So generally, multiple models are competing against each other, and data scientists need to interpret the model's results based on domain knowledge, the predefined success criteria, and test the design. Phase 5. Evaluation. So whereas the assessor's model task of the modeling phase focuses on technical model assessment, the evaluation phase looks more broadly at which model best meets the business criteria and what to do next. This phase has 3 tasks. First, we have to evaluate the results. So do the models meet the business success criteria? Which ones should we approve for the business? Then we have to review the process. Review its work accomplished, was anything overlooked, were all steps correctly executed, and summarize any findings. Then, lastly, we have to determine the next steps. Based on the previous 3 tasks, determine whether to proceed to deployment, iterate further, or initiate new projects. And lastly, we have got deployment. Depending on the requirements, the deployment phase can be as simple as generating a report or as complex as implementing a repeatable data mining process across the enterprise. A model is not particularly useful unless the customer can assess its results. The complexity of this phase varies widely, and it also has 4 tasks. First, we have to plan the deployment, so develop and document a plan for deploying the model. Then, develop a thorough monitoring and maintenance plan to avoid issues during the operational phase of the model. Third, we have to produce a final report. And then lastly, we have to review the project. So conduct a project retrospective about what went well, what could have been better, and how to improve in the future. Question 2. Explain what needs to be done before you can forecast time series. In other words, what does time series analysis involve? So, time series analysis is a very specific way of analyzing a sequence of data points collected over an interval of time. In time series analysis, analysts record data points at consistent intervals over a set period of time, rather than just recording the data points intermittently or randomly. However, this type of analysis is not merely the act of collecting data over time. What sets time series data apart from other data is that analysis can show how variables change over time. In other words, time is a crucial variable because it shows how the data adjusts over the course of the data points, as well as the final results. It provides an additional source of information and a set of order of dependencies between the data. Time series analysis typically requires a large number of data points to ensure consistency and reliability. An extensive data set ensures you have a representative sample size and that analysis can cut through noisy data. It also ensures that any trends or patterns discovered are not outliers and can account for seasonal variance. Additionally, time series data is part of a predictive analysis and can be used for forecasting, predicting future data based on historical data. Time series analysis is used for non-stationary data, things that are constantly fluctuating over time or are affected by time. Industries like finance, retail, and economics frequently use time series analysis because currency and sales are always changing. Stock market analysis is an excellent example of time series analysis in action, especially with automated trading algorithms. Likewise, time series analysis is ideal for forecasting weather changes, helping meteorologists predict everything from tomorrow's weather report to future years of climate change. And the following are examples of time series analysis. So we've got weather data, rainfall measurements, temperature readings, heart rate monitoring like EKGs, brain monitoring like EEGs, quarterly sales, stock prices, automated stock trading, industry forecast, and interest rates. Question 3. Discuss the main principles of data ethics, as well as what companies or organizations can do to uphold these principles. So, as a data analyst, we all need to be aware of the laws and regulations that govern how companies can collect and share the data, and have to follow those rules to the letter. The following are the main principles we should adhere to at all times. Transparency refers to clear communication of what data will be gathered, whether it will be stored, and who it might be shared with. While terms and condition documents can be long, convoluted, and almost require legal expertise, users should understand how the company will use the information. Accountability refers to an organization taking responsibility for what happens to an individual's data after collecting it. From data leaks to sales to a third party, companies need to accept accountability for the damage their process can cause users. Data privacy refers to one's ability to expect protection from public exposure of their data. If you consent to an organization to collect your data, you have the reasonable expectation of continuous storage, or use based on your initial agreement. Personally identifiable information, or PII, refers to any information linked to a person's identity, including the VIN number of a vehicle, voice signature, or telephone number. However, hackers and ethical technologists have been able to identify individuals with much less personal detail. While most organizations have a privacy policy and additional notice when collecting your information, what eventually determines whether they can uphold their end of the bargain is something completely different: its security protocol. The inequality refers to an analyst's ability to make meaningful choices about someone's personal data, whether it's the ability to assess, remove themselves altogether, or choose what collected information should be stored or used. Human bias will always be a factor and needs to be avoided at all times. So how can companies uphold these principles? Due to the scale of impact for most multinational corporations, developing reliable security, privacy, and ethics processes are even more critical. Corporations in vastly different industries have fallen victim to ransomware, leaks, and improper use of data by employees. However, claiming ignorance of these risks are no longer acceptable. Developing internal cross-departmental working groups is a valuable first step in developing company-wide shift in values and knowledge sharing. Expanding requirements, training for employees, and incentivizing regular analysis for managers and individual contributors will also communicate the value of ethical considerations related to the data for all. Question 4. Imagine you're an analyst at a financial services company and you have some concerns about bias in the way the predictive model was measured. How would you raise your concerns with your manager? Make some suggestions for how to avoid measurement bias in the future. So, measurement bias occurs when there's a problem with the humans doing the measuring, or the machines that they had built to do the measuring. As an analyst, should you come across measurement bias, it will be your duty to raise your concerns with your manager, or any results derived from the test could be skewed. You could ask for a one-on-one meeting and explain your concerns, then offer up some concrete suggestions on how to fix and avoid this type of issue in the future. The following suggestions could help reducing measurement bias in the future. Make sure that there are more than one measuring device. Ensure that any validators have an adequate and the same level of training and experience. More experienced analysts might be less risk-averse and could interpret the results differently than lesser experienced analysts. Then, make sure that your designs and communications to the rest of your team and stakeholders are open and clear. Your project's susceptibility to bias is very real, and they should know how you are planning to control for bias in your collection, measurement, and analysis. Then lastly, continue to evolve as the project goes along. Review and update your scoring and evaluation process when making a decision or designing your output. Go along with the majority of your fellow analysts and eliminate any outlier scores to hedge against individual bias. And this brings us to the last question, question 5. Explain the difference between regression and classification models in predictive analysis. When would you use one of these models over the other? So, the most significant difference between regression versus classification is that while regression helps predict a continuous quantity, classification predicts discrete class labels. Regression models show how one variable may affect another in order to make predictions, while classification models are a binary type of analysis. They predict the category an entity will fall into, like will they, won't they, yes, no, true, or false. So, let's consider a dataset that contains student information of a particular university. A regression algorithm can be used in this case to predict the height of any student based on their weight, gender, diet, or subject major. We use regression in this case because height is a continuous quantity. There is an infinite number of possibility values for a person's height. On the contrary, classification can be used to analyze whether an email is spam or not spam. The algorithm checks the keywords in an email and the sender's address is to find out the probability of the email being spam. Similarly, while a regression model can be used to predict temperature for the next day, we can use classification algorithms to determine whether it will be cold or hot, according to the given temperature values. And that is it. Thank you very much. Bye-bye.